So like a big strategy for me is coming up with as much information as I can, and that allows me to like pivot around that information to figure out whatever I can find out. And again, like sometimes like you might not need what you've written down, right? But I'm still gonna just try and think my way outside of this like box that I've been contained in by the problem, right? So theta, how could I find theta? There's a big part of this is just building some momentum with the problem too, right? Just doing something, right? And building towards that, Gabe.
50 degrees.
Okay, so we're gonna get 180 minus 40 minus 90 should be that theta should be 50 degrees up top. Okay, I'm getting somewhere. Now that I know that, I'm gonna try this. Could I figure that out? Phi? Sorry, is that what I want? No. I want phi to be this. Gabe?
We could, because 40's there, you could get the rest of the next angle, which would be, I think, 120. Yeah, because it's 180. This is a solid line, so it would have to be 120.
180 minus that 40, right?
Yeah.
So that beta angle is going to be 120. Okay, is everyone okay?
No, it's 140.
Oh, sorry. It's okay? Okay, now I can find that little phi up top, that blue angle. And then I'm kind of almost in business. I think I could start. Ultimately, what we want here is side lengths. Everyone agree? So, but I'm using, like, I'm just trying to build some momentum with the problem and just finding information. And, like, when you find information, that's just another thing on the triangle, right? That you could maybe pivot around. And so phi there. Phi is going to be that 32 degrees. It's 180 total. Minus the 32 degrees in the bottom corner. Minus that beta angle that I just found, the 140. So what's that leave us with? 8 degrees, right? We're in agreement? Okay. So if I were to like, that's 8 degrees. Beta is going to be that 140. And theta is 50. So what can I do now? Because you do know this chunk of this side length from here to here, right? So let's just for a second, with these compound triangles, sometimes it's helpful just to redraw one of the triangles and turn it into like a question that we've seen with grade 10, right? Like, I'm just gonna redraw this PQ and whatever the top vertex is. Vertex. It's not perfect, but we get the idea. So if this is 150, this is 140 degrees, this is 32, and this is 8 degrees. Oops. Is that big enough? Sorry, here. A little bigger. So let's just for a second think about what the intelligent choice is for which of the side lengths I should solve for. And actually, it might not matter. But then again, it might. So what, Gabe?
Why do you have 150 when it's 195?
Oh, sorry.
But we do have angle side angle, so we could do some
We have angles. What did you say?
angle angle, side angle.
Okay, you're thinking side angle side. That's that coleslaw sandwich. That's not what we have. We don't need cosine law. Although I think maybe there's a smarter way to do this. I think
Okay.
not cosine law, and not SOHCAHTOA either, right? Like I can't do SOHCAHTOA for this question or for this particular triangle because there's no 90 degree in it, right? So I can use. If I called this, I know we called it PQ, whatever, right? But if I called this A, B, and C, right? If I find, so I'll just highlight something for you. That yellow side length is this yellow side length. So my gameplay here is to find that yellow side length, which is the hypotenuse in that left triangle in my original picture. And then I could use SOHCAHTOA for that right angled triangle to solve for the height at the end. So if I find that yellow component, that yellow side length, I can use it in the other triangle. Right? So a good strategy when you see these like compound triangle questions is to solve for the side length that is shared between the two the two triangles. That's usually a good strategy. It's trying to find that shared component between the two triangles, and usually it's the side length. All right. So if I find that yellow side length using sine of A over A, okay, I'm going to use sine of A over A is equal to the sine of B over B because I'm interested in that side length B. Right? So I just fill in my information. I might need your help with this. Sine of 32 over 105 has to equal, sorry. Sine of 8 has to equal the sine of 32 over B. So B, all I'm doing here is cross multiplying and then isolating for B. So I should get, in isolating, I should get 105 sine 32 divided by the sine of 8. Does anybody have a number for me after they do that? $400 right on?
399.8.
Okay. So now if I go back to my original question, I now know that yellow component to be, could even really call it 400, but leave it. Okay, so the last part is now you have this right angled triangle. It's not going to do it. Right? Where you're looking for H, you know this is 40, and this is 399.8. So if I write out I can use SOHCAHTOA because I have a 90-degree angle in my triangle, right? And what am I not using? So if I'm standing here, this is opposite, this is adjacent, and this is hypotenuse. So what side length do I not care about at all? Adjacent. Everyone agree? So if I don't care about the adjacent side length, then I'm not going to use anything with an A in it, which just leaves me with sine. So I'm going to go sine of 40 has to equal h over, which is opposite over hypotenuse. That's what it tells me to do. And so h, the height of this triangle, is going to equal 399.8 sine of 40. Anybody get a number? Gabe?
So I got 256.98.
Okay, no, 256 is probably good. Or 257, sorry. We'll round that up. Okay? So there you go.